Hello, my name is Tiffany, and I will be presenting on my final year project, Chart-to-Text, a large-scale benchmark for chart summarization. So what is chart summarization? Chart summarization is the task of automatically converting a chart into a descriptive summary. These automatic chart summaries can be used for a variety of applications. For example, automatic chart summaries can serve as suggestions for journalists when writing data-driven articles. Chart summaries can also help the public to automatically extract data insights from charts. Furthermore, chart summaries can also be used as an accessible textual aid for the visually impaired to interpret charts. To train models for this automatic chart summarization task, we needed to build a dataset of chart summary pairs. We collected these chart summary pairs from two dataset sources. The first is Pew Research Center, and the second is Statista. After collecting our chart summary pairs from these two dataset sources, we trained 5 different models on the dataset. The first model is an image captioning model called Show, Attend, and Tell. The next model is the chart-to-text model, which is a transformer model adapted for the chart-to-text tasks. Then next we have the field infusing model, which is inspired from a concept to text work. Then lastly, we have the BART model and the T5 model, which are both sequence-to-sequence transformer models pre-trained on large datasets. Now let's look at the results of the models on the Statista and Pew datasets. First, let me give a little bit of explanation about the notation. The tab prefix indicates that the model is fed the underlying data table of the chart, whereas the OCR prefix indicates that the model is fed the OCR extracted text of the chart. For the OCR models with the asterisks, they are also fed the bounding boxes of the text. For the first model, the image captioning model, which is actually the Show, Attend, and Tell model, there is no prefix as the model is fed the chart image instead of the text. For all these metrics, a higher score indicates better performance, except for the last metric, perplexity, where a lower score indicates better performance. So for the Statista dataset results that you see on the screen, we observed that the models with large-scale pre-training, which are the BART and T5 models, performed significantly better than the other models, showing the benefit of this pre-training. And for the T5 model, we observed that the TAB T5 model performed better than the OCR T5 and OCR T5 asterisk for most of the metrics. This is likely because the OCR extraction process tends to introduce noise into the text, which causes the performance to drop. We also observed that the image captioning model performed worse than most of the other models, especially in terms of content selection, which measures its ability to retrieve relevant information from the chart. For the Pew dataset, we observed that the models performed significantly worse than for the Statista dataset. This is likely because the images in the Pew dataset consists of charts of a more diverse range of styles, and the underlying data tables in the Pew dataset were not provided, unlike the Statista dataset. That's why there are only OCR models and no TAB models. But similar to the Statista dataset, we also noticed that the models with large-scale pre-training, the BART and T5 models, perform significantly better than the other models. After training these models and looking at their outputs, we identified a few key challenges faced by the models in generating the chart summaries. The first was hallucination, where the model sometimes generates tokens that are completely irrelevant to the chart. The next is factual errors, where the model incorrectly reports data values and facts from the chart. Then there were also perceptual and reasoning challenges, because chart summaries are often expected to be able to describe complex patterns and trends found in the chart. However, identifying these patterns and trends proved to be a challenging task for the models. The next challenge we faced was computer vision challenges, where if the underlying data table of the chart was not provided, it was difficult for the models to be able to extract the data values from the chart image itself. And lastly, we realized that a lot of the automatic evaluation metrics that we use failed to capture the model performance in terms of factual correctness, hallucination, and successful generation of key takeaways. Here are the sources for the images I used in these slides. Thank you for your kind attention.